Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video we will discuss question number 12, NEET Physics paper 2016. Now students, let us solve question number 12. A siren emitting a sound of frequency 800 Hz moves away from an observer towards a cliff. So this is a cliff and an observer here. A siren emitting a sound of frequency this moves away from an observer towards a cliff. Observer towards a cliff at the speed of, so moving away from the observer and towards a cliff. So this you have to understand very clearly, because this means many things. A siren emitting, there is a siren over here, this is the source and this is the observer. The siren emitting sound of frequency is 800 Hz. So this is the actual frequency, moves away from the observer, this condition is satisfied, away with a velocity of 15 meters per second, and towards the cliff, the cliff is here. Then the frequency of the sound that the observer hears in the echo reflected from the cliff is. So the sound will move towards the cliff. Okay, this will move towards the cliff, and it will be reflected back like this. So this person will hear a sound after being reflected from the cliff. So what is the frequency that is heard by the observer? Take the velocity of sound in air as 330 meters per second. So this is the cliff, this is the observer, this is the source. Observer velocity is 0 because it is at rest, nothing is said about that. So V observer is 0, V source is 15, velocity of sound in air is 330 meters per second. The actual frequency is n, the apparent frequency heard by the observer is suppose n prime, that you have to find. So in this case, first of all, we have to the frequency of sound that the observer hears in the echo reflected from the cliff. So we have to find what is the frequency received by this cliff. Whatever frequency that is reflected from here will be heard by the observer. So whatever frequency that is received here is the same frequency heard by the observer, because this wall is not moving, this cliff is not moving, the observer is not moving, so whatever is being received here, that is also reflected and that is heard. So the frequency received by the cliff is suppose n, I'll call this as n prime and this I will call n double prime. So n prime is the frequency received by the cliff. So if the frequency received by the cliff, I will assume that this is the observer. If this is the observer, observer is raised and the source is moving towards the observer, that formula will apply. If I apply that formula, then n prime, the frequency received by the cliff is V plus, general formula is V plus minus VO divided by V plus minus VS. This is the general formula that we're going to use. and into the original frequency. This is the question. And in this situation, that the source is moving towards the cliff at rest, the observer, the source is moving, observer at rest, so I'll make it 0. This situation will become V divided by V, and the frequency will increase. Frequency will increase, so this will minus Vs into N. V is 330 divided by 330 minus velocity of the source, which is 15. So it is 15 into the actual frequency, which is 800. So this is 330 and 315 into 800. Then I have to solve this to get the frequency heard by the, so N prime is 330 divided by 315 into 800. If I cut in 5, then 5 is 63, 5 it is 66. So I have to use the value. If I solve this, then I'll use the calculator to do that, and that comes out to be a whole number, obviously. 63. 3 I can cut in 3, and this is 3 2s are 3 1s are 3 2s are 22. 9 3s are 21. This is a 21. Then I have to, it will be more than 800, little more than 800, that is for sure. If I don't solve this and see, it is little, because if it is 21, you can see that if it is 21, then it will be 800, because this is more than that, so it will be more than more than 800. So I think this will be the answer, but then we have to solve it with the help of your 21. I have to divide that, then no problem with that. 22 over 21. How much is this? 21 1 jar 21, 1 is left, 1 and 1 0 is there, obviously. 6 6 okay, that is okay, no problem. The 0 is cancelled. Now 1.22 by 21, that is 3 7s are 3 7s are, so 1 is left. 0.00 100 by 21 is approximately 5. I'll take 1.05. If I multiply 800 with 1.05, I'll multiply 100, then I'll shift the value, or okay, 800 into 1.05, that is 8 into 105. So this way I can do that. Then it is 840. I'm getting 840 approximately. I'm getting this way. I'm approximately getting 840 Hz, and this way you should solve, because the number is such that if you go on for actual calculation, it will take more time, and then you will not be able to solve the any other questions. So therefore it is around 840, which is the higher value, so little less than 840. It is never more than that, because I have rounded up to 5 here. So it is 838. you go and see it, calculate, you will get 838 hertz. So this is the value that this cliff is receiving, 838 hertz. So this one is correct, and because that it is emitting that 838, because it is emitting 838, so this same thing will be received here. So n double prime will be 838 hertz. So finally the observer hears the echo reflected from the cliff will be same as this. So that is the answer to this question. Okay, thank you.